If you haven't done so yet, please pause the video and try to solve the question on your own before listening on. To solve this question, we need to look at the equation that relates resistance, temperature, and the temperature coefficient of resistivity. Now, in this equation, the R's represent resistances, but in the question, we weren't actually given any resistance values. We were only given current values. And so in order to proceed next, we need to consider Ohm's law, which tells us that the potential is equal to the current times the resistance. What we're going to do is solve this equation for the resistance by dividing both sides by I. And when we do that, we can see that the resistance is equal to the potential divided by the current. Now, this would be true for the resistance R. It would also be true for the resistance R naught, as long as we put a little naught symbol next to the current. So what we're going to do is replace R in the above equation with V over I, and replace R naught with V over I naught. Now, we will next notice that the question says that the potential difference was the same. That means that these two V values are the same, and what's nice about that is we can multiply both sides of the equation by 1 over V, kind of squeeze it in right here, and what's going to happen is the V's will cancel, and that's going to leave us with 1 over I on the left side and 1 over I naught on the right side. Now, what's nice about this is that we now have the equation in terms of currents, and that's exactly the information that was given in the question. So we're now ready to solve for the temperature coefficient of resistivity, which of course is alpha. And in order to solve for alpha, what we could do first is multiply both sides of the equation by I naught. And if we do that, we can see that on the right-hand side, the I naughts will cancel. We could next subtract 1 from both sides of the equation. And then finally, we could divide both sides of the equation by the term t minus t naught. On the left side, we're going to be left with a complex fraction, but that's okay. We'll be plugging in all the known values in just a moment, and that'll help simplify it. And indeed, we are ready to plug in the known values. We just have to be careful about how we match up the current with its respective temperature. So for example, we can call this current the I naught, as long as we call this temperature the T naught. And then we would call this current the I, and then this temperature the T. And so with that in mind, we can plug in those values into the equation. Notice that the unit of amps will cancel, and when you process this on your calculator, you get approximately 0.00676, and then the unit, since we have degrees Celsius in the denominator, will become degrees Celsius raised to the -1. So this would be the correct answer to the question. Thanks for taking the time to watch the video. If you liked it, please click the thumbs up icon and also subscribe to the channel so you could stay tuned for additional videos. Remember that you're welcome to send in your own question to this email address, and I'll do my best to answer it on YouTube.